Rust's ownership system is one of the features that sets it apart from other mainstream programming languages. Some programming languages has what's called a garbage collector that runs in the background and checks for unused memory. Other languages requires that you explicitly free and allocate memory. Thanks to the ownership system, you don't have to manually allocate and free memory, and you also don't pay the penalty of having a garbage collector running in the background. We're gonna talk about 4 aspects of the ownership system: move, copy, borrow, and borrow mutably. A move happens when you pass something that is not a copy type, for instance, a string. If I create a function that takes a string as an argument, and I call that function with this string as the argument, it means I am moving the string into that function. This code will compile. However, if I try to use the string after the move, we'll get an error. This is because the string was moved into the function. Thanks to this, Rust knows when to free the memory for a variable. Because the variable s is no longer used after the function called useString, the variable s is freed here. So what about copy? Well, unlike move, copy types are copied. So which types are copy types? That would be numbers and boolean values. Let's create a function that takes a numerical value, an unsigned 32-bit integer, as its argument. Just like with the string, let's declare a variable and pass it to the useNumber function. Unlike the useString function, useNumber doesn't take ownership of the number, but rather creates a copy of it, so we are free to use the number again after we call that function. So why are some types copy and some types move? Well, a string could be a very large object in memory. We have no idea how big a string is, right? So copying that everywhere we use it could become very expensive. Numbers, however, are very small in memory, so they are very cheap to copy. So how do we pass multiple strings around? Well, since a string is potentially large, it would be better to pass a reference to the string. This is where borrow comes in. Let's create a string variable. Like before, we create a function that takes a string argument. However, in this case, we won't take ownership of the string, we'll get a reference to the string. You can tell that we're taking a reference rather than moving, since there's an ampersand in front of the string. We can now call this as many times as we want without moving the actual string. Because this is a borrow, it means that we cannot actually mutate the underlying string. If we try to do so, we'll get an error. We can, however, use the string without mutating it. But what if I want to mutate the string? Well, all we have to do is change ampersand string to ampersand mute string. However, before this compiles, we also have to change string to be mutable, and we have to pass a mutable reference. There is a caveat with the mutability, and that is that you can only have one mutable reference at a time. Let's update our code so we only hold one mutable instance. Now we'll borrow some data from the string using the get function. What the get function does is not important. The important thing here is that we have borrowed some data from the string. And now, what happens if we borrow the string mutably and change it? The borrowed data we're pointing to is no longer valid, so if we try to look at this data, we're gonna get a compiler error. This error, while frustrating, is preventing you from looking at data that is no longer there.